Okay, so on example 6 is more the same, careful, more the same, except instead of doing it in the noun format, it's in the verb format, okay? The noun format is basically, here's a function, y equals or f equals, what's the derivative? F prime dy dx. But we could really do the same thing with an expression rather than an equation. So that's what we're doing on example 6. We read this as the derivative with respect to x of 5 over 2x to the square root of 2th power, or the derivative of that with respect to x. But it's a verb, okay? So there's no equal sign. There's no instructions other than possibly evaluate. But it's really the same thing. So what do we need to do in order to successfully take the derivative of this expression? Is it in the right format? No. So that's always the first step. Size it up. And once you decide that you're going to use the power rule, you need to put it in that power rule format. So the problem is we have to rewrite the instructions with it as we work straight down. 5 over 2, x to the what power would it be? Negative square root of 2th power, okay? Now, if there's ever a time where like you need multiple lines to put it into a certain format, you might want to go off to the side in your workbench and do that and then bring it back in, because the ddx is pretty intensive, right? Now, again, we read this as the derivative of, there's an of in here, this expression with respect to x. Is there an equal sign anywhere? No. When we work straight down, the equal sign is implied. If you want, you could put one equal sign over here, remember, and then put this, and then from there you work straight down, okay? But I'm not going to do that because I like working straight down, and we don't need the equal sign. Now here's what you don't want to do. Just like when people were evaluating limits, we did the limit as x goes to whatever a, and they put equals. That doesn't make sense, right? The limit of, right? There's supposed to be something here, of, and there's nothing there. Same thing here. You don't want to put the derivative with respect to x equals something, because guess what? It needs to be of something, all right? It's an operation. It would be tantamount to essentially having the natural log of nothing, right? So notation, notation, notation. Thank you. All right, so right there. Yeah, okay, good. Yeah, now, is it ready to go? I think it's ready to go. Ax to the n. So we multiply, subtract. When you take the derivative, you don't write the ddx anymore, okay? So you multiply and you get negative 5 square root of 2 all over 2 times x to the negative square root of 2 minus 1th power. You might want to put that in parentheses just to hold it together. Now, here's why you don't have to write the ddx anymore. Where does it go, you ask? Well, it's actually still there. It's going to be times the derivative of the variable with respect to x, okay? Since this is an x, the x is there. Now, guess what dx divided by dx is? It's 1, so we really don't need it, okay? We really don't need it. So that's where it goes. And then technically we're done, right? This is the derivative. It's not in cleaned up format, but we could do that. Negative 5 square root of 2 all over 2. And then when I bring that to the bottom, remember, both signs in the exponent changes. So it becomes the square root of 2 plus 1th power. And again, it's not a bad idea to group those together in parentheses. All right. Yeah, is it plus 1 or minus 1? We changed the sign of the exponent. So if you imagine putting a negative out front with the parentheses, you would distribute. So it does change both signs. Yes, Lord. When we learn the chain rule, it'll be more obvious, but essentially you can pretend like it's in parentheses and you can't really see it. So you multiply and subtract, and then what we're going to learn when we learn the chain rule is we're going to go ahead and then multiply by the derivative with respect to x of whatever that variable is. Okay, and it turns out that dx is 1. So right now, don't worry about it. Just like with the limit, once we evaluate the limit by direct substitution, the limit can go away, yes? It's like we're evaluating it. Whenever I actually take the derivative using the power rule, on the next line, the ddx goes away. So for right now, just think about it that way. But there will be a better explanation later. Okay, do we need to rationalize the numerator? Or is it okay to have a radical up top? Sure, it is okay. Yeah, it is okay. But let's see what it would look like. Like, I'm thinking like a multiple choice answer. You know, maybe that's not even the answer choice. If I multiply by root 2 over 2, that would give me -5. And then root 2 times root 2 is just 2. And in the bottom, I have 2 root 2 times x to the square root of 2 plus 1th power. And what would happen with the 2's? What do we call that? Dividing out, good. And so another equivalent answer would be -5 over square root of 2 x to the square root of 2 plus 1th power. I don't know if that's any simpler, but it does appear to have one fewer factors, right? So anyway, multiple choice. All right, go ahead and do B on your own. Simplify early, simplify often. In fact, do the rest of them on your own. Just do the next 3, run it out. And then we can stop there and talk about the test. How about that? Oh, yeah. Let's talk about test, baby. Let's talk about you and me. Let's talk about all the good things and the bad things that may be. Let's talk about test. Let's talk about test. The original lyrics, I'm not sure what they were. Something else. Something else. 3, 2, 1, here we go. All right, here we go. Letter B. The derivative with respect to x of 4 over the quantity 2x cubed. Simplify early and often. Now, just a little note about this. If we just had 2x quantity cubed and we were asked to take the derivative of just that, it is not going to be 3 times 2x to the 2nd power. That doesn't work because it's not in ax to the nth format because this base is not plain old x. All right. There will be a rule later on for doing it like that, but that's called the chain rule. So right now, it literally has to be written as the number times a power of x. So if you're going to simplify this, since we have a positive exponent in the bottom, it's easier to simplify when you have positive exponents rather than negative. So 2x quantity cubed, remember, is really 2 cubed x cubed, or 2x times 2x times 2x. So 2 cubed is 8, and x cubed is x cubed. So that would be the first step. And now we can simplify, and this is still d dx, right? The verb 4 over 8 is a half. Bring the x to the top, and you get x to the -3rd. Okay? Now, if this were a multiple choice question, guess what one of the answer choices would be? It would be 1/2 x to the -3rd. Because as you're rewriting it, you get to a point where you've done a couple of things, right, mathematically, and your answer is there, and you're like, that must be the right answer. But at this point, have we even really busted out the calculus yet? No, we haven't busted out the calculus. We're just rewriting it so we can bust out the calculus. Now it's time to BOTC, baby. Bust out the calculus, right? A times x to the n. So when you do the power rule, multiply and subtract, that's where you abandon the ddx. So you get -3/2 x to the -4th. There you go. And now when you rewrite it, -3 over 2x to the 4th. So notice it's algebra, Bust out the calculus. Algebra, algebra. Calculus took up one line. Algebra on the front and back end. Okay? Questions on that? Bust out the calculus. It has BC in it, right? All right. I don't want to have to. My voice is going out, and it's still early in the week. Hey, good thing I don't have pep rally this week. Well, not good thing, but you know. Hey, this one is with respect to T. I have two T's, don't I? So rewrite the instructions. That's going to be, if you want to do it in slow motion here, right? You got 3t to the 1/2. You need to be able to combine your exponents, right? So when you're subtracting and the bases are the same, you do subtract them. So we're going to get 7/3 times t off to the side, which is really the numerator. 1 minus 1/2 is 1/2. Now at that point, we haven't really BOTC'd yet. We're just doing algebra. Now we're ready to BOTC, bust out the calculus. Let's get the good stuff out. Multiply. You get 7/6. 7 times 1, 3 times 2, times t to the 1/2 minus 1 is negative 1/2. And that's the answer. And now if you want to clean it up, 6 could be a placeholder in the bottom, and then the t jumps back down there. So again, algebra, algebra, bust out the calculus, algebra, algebra. Calculus is usually just one line. I'm working straight down. There's no equal signs. If you want to work horizontally, you can, but it would look something like this. You don't ever work horizontally more than 2 lines. Yeah, once, right? 2 expressions, 1 equal sign. All right, letter D, the derivative with respect to m. Now, again, it's easier to expand when you have positive exponents. So what I'm going to do, since the whole quantity is to the negative 2th, I'm going to bring the whole quantity to the top and say it's to the positive 2th power. And now I'm going to expand it in the numerator. So I'm going to have a 6 times 3m quantity squared is 3 squared m squared, right? Again, just the rule is because they're all factors, you could just distribute the 2. And of course, simplifying one more time, 6 times 9, you get 54 m squared. And that would be a good answer choice, but we haven't really BOTC'd yet. Now it's time to BOTC. Bust out the calculus, multiply, subtract, you get 108 m to the 1st. And that's your answer. There doesn't even need to be any simplifying. Okay? So there you go. All right, we'll stop right there in the notes, and then you won't have that. But look, let's look at I just pulled the one test up. And I pulled up the test from, this was from 2000. This is the most recent test. This is 2000 and, where was it? I forgot what I opened. It was actually this one. The 2.1 to 2.3 2018 test. I just opened the key. Nope, that wasn't it. Oh, crap. Yeah. 2017, 2.1 to 2.3. And again, I'm not saying it's going to be this one, but I open it up and right away I'm liking what I see. The first one is nice. It's kind of taking it to the next level. You basically say k is a constant, the tangent line, what's the value of k? We might have to wait on that one. But I do like 3, right? We've already seen ones like this where we force it to be continuous, but now we can force it to be differentiable. But we haven't really taken the derivative of a piecewise function yet, so maybe I like that one for the next test. Number 4 I like, but that's multiple terms. We haven't learned the sum and constant difference rules yet. No, they're good. Here's what I'll tell you. All of them will. If you have multiple terms, you can use the power rule on each term down the line. First term, second term. Yeah. I do like 5. 5 is a banger, right? Boom. Right? Deconstruct. Number 6 is awesome. I like 6. So yeah. Number 8 is good. Number 8's like the warm-up, but even easier. 9, I will just say again, if you're taking the derivative of multiple terms, you just take the derivative of each term one at a time. Maybe, yeah. Yeah. Can do, yeah. All right. We'll see y'all tomorrow. I will be here, not after school. I have a meeting, but I'll be here 7th period, and I'll be here in the morning. All right. Have a great day.